back for round two. I promise this is the last time you have to see me today. I'd like to discuss an upcoming acoustic telemetry project that's aimed at assessing the effect of legacy mining materials on movement and spawning behavior of two fish species in Michigan waters, Lake Superior. Glyphwick, along with partners and support from the Keweenaw Bay Indian Community, the USGS, Michigan DNR, Great Lakes Fishery Commission, Michigan State University, and Great Lakes Restoration. We're currently in the process of developing this project, which will begin this fall. And before I get into the telemetry project, I'd like to give some background information regarding stamp sand and the importance of Buffalo Reef. So the Keweenaw area has seen its share of copper mining throughout the last century. Between the mid-1800s and 1929, the Keweenaw area was the second largest producer of copper in the world. And by 1968, 4.8 million tons of copper were smelted and 360 million metric tons of stamp sand were dumped into inland waterways and along Lake Superior shoreline. So in our study area near Gay, Michigan, the Wolverine and Mohawk mining companies operated stamp mills, much like the one pictured on the bottom left. This was done during the early 1900s, and both these companies closed by 1932. And throughout that time period, about 22.7 million tons of stamp sand material were deposited in Gay, Michigan, right on the shore of Lake Superior. And for those of you that are not familiar with what stamp sands are, it's a byproduct of a crushing process that's done by stamp mills. The stamp process is basically used for breaking down large rock to facilitate extraction of metals such as copper. The stamp sands also contain toxic levels of copper for aquatic ecosystems and other metals that can be harmful to aquatic life. And habitat loss is also an issue, as stamp sands can potentially smother habitat that's important for aquatic vertebrates and invertebrates. And Buffalo Reef, which is denoted here by the red border, is located near Gay, Michigan in Grand Traverse Bay, which is located on the eastern side of the Keweenaw Peninsula. The reef is a shallow cobble bedrock area measuring around 2,200 acres and ranges from around 14 to 55 feet in depth. And as evidenced by Glyphwick's annual fall gillnet survey on Buffalo Reef, it's apparent that it continues to be an important spawning area for lake trout and whitefish. Unfortunately, the reef is still under threat from stamp sands that were deposited by the mining companies that I mentioned earlier. The threat could impose loss of harvest opportunities for both angler and commercial harvests, and would also hinder the ability for Ojibwe people to exercise their treaty rights in this area. So just to illustrate the importance of Buffalo Reef, this graph shows the abundance of spawning wild lake trout, which are the orange bars, and whitefish, which are the blue bars. And this is from Glyphwick's fall gillnet survey on Buffalo Reef over the past 10 years. The orange dotted line represents the targeted effort for lake trout, and the blue dotted line represents targeted effort for whitefish. So catch per effort for lake trout during this time period was as high as 261 fish per 1,000 feet of gillnet, while whitefish catch per effort was as high as 111 fish per 1,000 feet of gillnet. This box plot compares lake trout catch per effort among some of the other nearby reefs. And we see that lake trout catch per effort for Buffalo Reef, which is indicated by the red font, is fairly high when compared to Betsy Bay, Big Bay, Huron River Reef, Traverse Island, and Traverse Point. For whitefish, catch per effort is more or less comparable to other reefs, with the exception of Huron River Reef, where we see the highest CPEs. So as for the commercial importance of Buffalo Reef, it's likely contributing to a sizable proportion to the total combined lake trout and whitefish harvest within Michigan 1842 treaty waters of Lake Superior, which is represented by the black bars. And total catch within 50 miles of Buffalo Reef is represented by the beige bars, and the green line shows the percentage of harvest that occurs within 50 miles of Buffalo Reef. Also, Earth Economics is currently drafting a report that looks at the ecosystem service value throughout the Keweenaw Peninsula. This value is associated with the goods and services that ecosystems provide. Some of these include, but are not limited to, food, medicine, water storage, water quality, air quality, recreation, and tourism. It's estimated that the ecosystem service value for the Keweenaw Peninsula region lies somewhere between $613 million to $1.5 billion per year. And if Buffalo Reef habitat was completely lost to stamp sand, the estimated hatchery production cost alone to maintain the current level of harvest would be around $4.9 million per year. Okay, so throughout the last century to present day, wind and wave action have gradually eroded the original stamp sand pile near Gay, Michigan, which is denoted by the black arrow in the upper right corner. And this has caused the stamp sands to migrate southwest along the Lake Superior shoreline. The dotted white line shows the distribution of stamp sand, what it was back in 1938. So you can see that a lot of this material has moved quite a bit since then. And not only has this material covered much of the shoreline to the north of the Traverse City seawall, it has unfortunately made its way on a Buffalo Reef, partially covering fish spawning habitat. Michigan Tech University has estimated that nearly half, or around 10 million tons, of the original stamp sand pile has migrated into Grand Traverse Bay, posing a threat to Buffalo Reef. And according to some other research conducted by Michigan Tech, about 30% of the reef is currently covered with stamp sand and will be 60% covered within the next 10 years if no action is taken to thwart the migration of stamp sand in this area. So if you look at the substrate distribution map, the red color is the distribution of the stamp sand. Green is bedrock, and kind of the darker green is stamp sand and natural sand mixture, and the orange is natural sand and cobble. So the Army Corps of Engineers plans to dredge approximately 130,000 cubic yards of stamp sand that has fallen into a natural trough just north of the reef. And this is being done in the hope that the migrating stamp sands that would otherwise make its way onto the reef will instead fall inside the dredge trough and possibly buying a few more additional years while a much needed permanent solution to control and remove stamp sand is being developed. So currently a multi-agency task force, including tribal, state, and federal agencies, they're investigating potential long-term solutions for controlling the migration of stamp sand. So this picture here is just to illustrate the difference between stamp sand and natural white sand in Grand Traverse Bay. You can see how the sands are moving down the shore from the north and accumulating behind the north breakwall at the harbor, and even spilling over inside the harbor channel, which I've highlighted with the red circle. And this is keeping the stamp sand from encroaching onto the natural sand beach immediately to the south of the channel, at least for now. And if the sand were to travel around the wall and back onto the beach, the natural sand beach, not only would this smother valuable whitefish nursery habitat, it could also move onto Traverse Point, which is another nearby spawning area. Fortunately, the U.S. Army Corps of Engineers has plans also to remove around 27,000 cubic yards from the canal and the adjacent area just north of the breakwall. And this just gives a different perspective of the red circle area from the previous slide. So in this picture, the camera is on the north breakwall, facing southward toward Traverse Point, which, as I indicated earlier, is another spawning reef near Buffalo Reef. You can see that how the canal is being choked off by stamp sand and potentially posing a hazard for boat traffic. And immediately south of this is the native sand shoreline. And these are just a couple more pictures showing different perspectives. One is from our research vessel, kind of going straight east out into the lake, and the bottom picture is from the north breakwall, kind of facing out toward that same general direction. So the negative effects of these sands are already apparent. For example, a study done by Michigan Tech in Grand Traverse Bay shows that aquatic invertebrate density is severely reduced in areas covered by stamp sand when compared to areas with little stamp sand coverage. So if you look at the left side of the graph, this is substrate that contains mostly white natural sand beach. And as you move further to the right of the graph, you get more of a mixture of the black stamp sand. So you can see that these aquatic invertebrates, they're just not making it on the stamp sand. And furthermore, nearshore samples collected in Grand Traverse Bay during Gliffwick's summer beach stain survey indicate relatively low abundance of fish and less species diversity from samples collected on stamp sand, which are represented by the black bars, when compared to the samples collected on the natural sand, which is represented by the white bars. And some of the more common species that we see on the native sands are lake whitefish, rainbow smelt, and spot-tail shiner. So in response to the threat that stamp sands pose to spawning habitat in Buffalo Reef, personnel from Gliffwick, KBIC, or Keweenaw Bay Indian Community, USGS, Michigan DNR, and Great Lakes Fishery Commission have partnered to implement a project that aims to look at the effects of stamp sand coverage on lake trout and whitefish movement and spawning success within this area. So our specific objectives are to, one, determine where on Buffalo Reef spawning is occurring. So are fish spawning on habitat that have been covered by stamp sand, or are they avoiding stamp sand covered habitat? Objective 2 is to determine if spawning habitat use changes over time, and this is going to be done in response to whether stamp sand cleanup occurs within the near future, or if no cleanup action is taken and stamp sand migration becomes worse on Buffalo Reef. Objective 3 is to determine the potential effects of the stamp sands on spawning success. So we're going to be looking at egg and larval survival and development on areas affected by stamp sand. And objective 4 is to determine post-spawning spatial distribution patterns. So we're interested in figuring out where fish disperse to after spawning on Buffalo Reef, and if they're moving on to other reefs around that same area, or maybe movement to those other reefs might increase if we see stamp sands continue to cover Buffalo Reef. So in order to answer objectives 1 and 2, a VPS, or a VEMCO positioning system array, with each receiver being spaced by 500 meters, will be deployed across Buffalo Reef throughout the lake trout and whitefish spawning season. And the goal is to tag 20 fish of each sex for each species for a total of 80 tagged fish. The type of tags that we're planning to use are the V16 tags with the larger 6H batteries, since we'll be tagging fish that measure around 20 inches or greater. And we intend for this to be a multi-year project, so having the extra battery life will be advantageous. And the receiver type that we plan to use is a VR2W 69 kilohertz model. For objective 3, lake trout and whitefish egg deposits will be located with scuba divers on Buffalo Reef. Egg and larval fish traps, somewhat similar to the ones pictured here, will be used to compare hatching and larvae development on areas affected by stamp sands versus areas not affected by stamp sands. And for Objective 4, acoustic receivers will be deployed at 5 different locations: Betsy Bay, Traverse Point, Traverse Island, Big Bay, and Manitou Island. This is going to be done in order to gain more information regarding the pre- and post-spawn fish movement for lake trout and whitefish. And this picture here shows the current distribution of receivers that are being deployed for other projects, such as the Lake Sturgeon Movement Project along the south shore of Lake Superior, and the receivers located in Canadian waters are, I believe, mostly ones looking at walleye movement. So we'll be interested in picking up, detections from our tag fish on those other receivers. So we're currently in the planning process of this project. Fall of 2019 is when we plan to deploy the array and begin tagging fish. Mike Lowe, who's a postdoc out of Hammond Bay Biological Station, will be the project lead, and we look forward to presenting the results to you in the future. So with that, I'll take any questions.